Hello everyone, welcome to Intrinsic Intelligence YouTube channel. Today we are going to discuss on 12-factor app. 12-factor app in general is used where we need to create a software as a service, be it a serverless application or microservices application. So all these 12 factors that particular, let's deep dive into 12-factor app. So coming back to the introduction. So in the modern era where we could see software is becoming as a service, so software as a service or platform as a service or infrastructure as a service, even we are you're hearing about security as a service. So a 12-factor app can be applied basically when we create any application or a web apps or a banking application. So this could be used by any engineer, not only developer or DevOps engineer or ops engineer, or who could be involving in database administration. This low level design of making an app cloud ready or making it as software as a service, and it could be improved development or deployment purpose, be it an SR engineer can adapt to this 12-factor app. So these are all the 12-factor apps. So the first one is the code base, dependencies, config, backing services, build, release, and run, and processes, port binding, concurrency, disposability, dev pod, parity, logs, and admin process. Yeah, don't worry, we are going each factor in depth in the upcoming slides. So let's move on. So the first 12-factor app is a code base. So what it basically says, there should be one code base which should be in a revision control, be it a Git or SVN or a GitHub, and that particular version control code base should be deployable in multiple environments. So as we could see this representation, there is a one code base, and the deployment could happen in production, staging, dev environments, or integration environments, or be it in a pack environment such as pre-prod. So there will be one code base, and multiple versions of the code is deployed across each deployment environments. That this mentions on the first 12-factor app, which is the code base. The second one is on the dependencies. So dependencies should be explicitly defined, meaning it should not be system specific, or suppose we develop an application which is developed in our local machine and deployed in our in-house platforms or the deployment environments. It should not rely on that particular environment configurations. So dependencies should be packaged when we develop and deploy. We are using a Java application. We could use very well a Gradle package management tools to package our entire project into one executable jar or war files, and it could be defined, like what are all the dependencies are there, could be defined in a manifest file so that it is readable and it is portable. So dependencies should be explicitly declared, and as well as it should be isolated. So this is the second in the 12-factor app, which is dependencies. The third one is the config. So, so what it defines is like config should not be defined within the code. Like in most of the traditional cases, there could be constants, like or a global constants which maintains the config. So it's not in the case of a modern application development where we should separate out the config from the code bases. So the config should not be integrated into the code. It should be separated out, and then it should be maintained in a separate revision control or separate environments. And each environment will have different configs. Suppose it could differ in prod, and the configuration might vary in integration and acceptance and development environments. Next, the fourth 12-factor app is backing services. So what are backing services? So when we develop an application from the scratch, like in a Java project, like we use like basically what we use Java, Maven, and then we start from the scratch. But we will be relied, of course, or dependent, of course, on the event systems like Kafka or RabbitMQ, or we could be dependent on the on any cache memory like Redis or Memcache. So all these backing resources should be treated as attached resources, meaning there should be an URL authentication host post URL defined in the configurations, and it will differ for each deployment environment. So suppose if you could see example of where the diagram shows the production deployment, where it depends, the application depends on MySQL, email outbound service, Amazon S3, and the Twitter. So these are connected via URL, which also has authenticated information, host, ports. So basically, these are all dependencies are treated as the attached resource. Let's move on. So the fifth 12-factor app is build, release, and run. So what it basically says is, the build process, the release process, and the executable process should be separated out. Meaning, in our modern application development, we use the build. We have a separate CI pipeline for Jenkins, and we have for deployment we have a separate CD pipeline for building deployment, building a jar out of it, and jar or var file out of it. So we have build and release, and for running an application, maybe we will depend on Kubernetes, Docker, Kubernetes, and we have Ansible scripts to manage it. So this build, release, and run should be separated out. And then the sixth 12-factor app is process. So we have consider a microservice. We have, like, of course, consider an application which has 20 to 25 microservice, and each microservice should be treated as a statelet process, and each microservices could be deployed at any number of instances. Suppose a microservices number 5 could be deployed in 4 or 5 EC2 instances, because it might have the more load compared to other microservice in the app. So this 12-factor app states that it should be stateless and share nothing. So each microservice in an application should be independent, and it should run individually as a single or more stateless processes. The seventh 12-factor app is port binding. So the 12-factor app states that we expose the microservice as a HTTP methods, and each microservices should be tied to a port. So in an EC2 instance, it can have, like, out of 25 microservices, which we spoke about in the previous example, and there could be, like, 4 microservices could run on a single instance, where it is defined and binded to a particular port, and what are all the dependent microservices dependent on other microservices should be listening to this port. So there should be a port binding. And the eighth 12-factor app is concurrency. So in the concurrency is basically like running multiple instances, like we discussed in the previous few minutes back, where if you could see this diagram where you have a web service, there could be multiple worker threads, and it should worker threads or instances, like suppose the microservices can be scaled out as and when we need it, depends on it depends on the load it faces in the production. So concurrency basically is a process where it could scale out as and when needed. And the ninth 12-factor app is disposability. 12-factor app enforces a fast startup. Suppose if the microservices need to be bring up quickly, how fast is getting deployed into the required instances. This is one of the most important point in disposability. And the second point on the disposability is like the grace shutdown. Suppose if any fallback happens, or the system breaks, the microservices instance which are executing should be gracefully shut down, meaning it should not corrupt any backed services or dependencies or any of the configurations. So it should be fast startup and a graceful shutdown. So this ninth 12-factor app disposability defines these two principles. The 10th one is dev prod priority. So what 12-factor app suggests is like, of course, the dev environment and prod environment will have lot of differences. What it states that we should minimize as much as the gap between the dev and the prod environments. So we should minimize the gaps. Like in a traditional environment, like the deployment happens every month or a couple of weeks later. But in the modern application development, the deployment could happen like for the same application. There could be two production deployments can happen in a single day. So we should minimize the differences between the development and the production environment. So we could see the differences between traditional and 12-factor app. So time between deploys in traditional app, it could be week, app, it could be hours. And in code authors versus code deployers, it could be different people. But in a 12-factor app of a modern system development, it could be a same person. So the dev and the production environments in the traditional app will be divergent. There are a lot of configurations which are not available in the dev environment where it is available in the production environment, where people end up seeing few of the scenarios failing in the production environment, and it could be surprises. In the 12-factor app, it is maintained as similar as possible in terms of configurations, dependencies, back services. So in the code version control, there could be a minor differences, but the production deploys happens frequently. There would be as similar as possible with minimal gaps. So the 11th 12-factor app is logs. So we should treat logs as an event stream. So the 12-factor app based application will not store any of the output streams. It will pass it on to a log file, or it will pass it on to the event streams where it will send it to the particular log management environment or instances, and from there it could be either Kibana or Splunk we could see the results as an Elasticsearch, and it can scale out as and when possible. So these logs should be given to the output streams, or such as Kafka streams or RabbitMQ streams, which puts the data into the log management system. So the final factor of the 12th factor app is the admin process. There is so in any application there could be a lot of admin processes. It could be a database upgrade, or it could be Kafka certificates are expired and they need to update the certificates, and there could be a CAD environment, or where they could increase the versions, or they could migrate from RHEL 7 to RHEL 8. So these are all admin processes which are one-time processes. So these processes should be kept separate, and should be run as a one-time process, so that it does not affect the regular or automated process which we have for the development and the release. So these are all the 12-factor apps which we are talking about. And thank you for spending and watching this video. For more such videos, please follow our YouTube channel, Intrinsic Intelligence. And if you want more such contents as a code, we could my GitHub URL, which I provided here. Thank you, and have a good day.